All right. So, okay. So hopefully everybody's starting to get a handle on how this class works. We will be starting to pick up not the heat or the pace, but like there are a couple of conceptually we'll be, we are going to keep hammering on for loops and we're going to keep hammering on for loops, and we're going to keep hammering on turtles. In fact, that's the focus of today is talking about for loops. We're going to talk about them both abstractly with regards to how it works with turtles. You'll notice that in a lot of my lectures that, especially around for loops, that I'll speak about them as though I'm talking about them for the first time, and I haven't introduced them in class before, or in your textbook, or in the textbook, or in any of the videos I provided, right? Because I believe that basically with these concepts, explaining to them as though they're new multiple times really does help, because they aren't. The ideas behind them aren't hard, but the syntax and the kind of mental keeping track of things is different than what you normally have to do. Now, this is currently week 3. Our exam will be in week 6. I should have a better idea of how and when I'm going to be giving the exam during week, next week. I suspect that most likely the exam will be in this room, just simply to give you all the exam, and then that way you still have plenty of time to work during your labs. Or I might decide to do it during the labs, but then I would have to possibly make different versions of the different versions of the exam in order to make it fair, which, and to avoid avoid any leakage. So, they both have their benefits and they both have their drawbacks. If you're unable to bring, but again, I'll make announcements of that. Regardless of where and when we do it, you will be getting a practice exam. The practice exam I wrote a number of years ago, but it's still relevant. The practice exam is paper-based, and it is much longer than the actual exam would be. But I think that's a good thing since if you're taking a practice exam, you probably want more practice problems. So yeah, this question? Your exam will, ideally your exam would be on a computer on Canvas, but for those of you who, but for those of you who have not learned to respect Murphy and his law yet, I will have paper backups ready to go. So in case things go wrong in the middle of the exam, you'll be able to, your progress will be saved, and then I can just simply use your paper exam as a reference. In terms of resources for the first exam, because of the nature of this exam and the way this exam works, there's not this exam and only this exam will be basically closed book, no resources other than no resources other than what's in your brain. And the reason for this is that a lot of questions are simply going to be of the nature, okay, here's some code. What is the output of the code? Or what gets drawn when you run the code? If I let you run the code, kind of defeats the purpose of that. And these are some of the best questions that I can ask that also are, fairly straightforward and easy to grade. Now, as for the second and third exam, it's going to be a lot different because at that point I'm testing, can you do specific tasks rather than understanding of these fundamental concepts. So, keep that in mind here. But again, a lot of the stuff is just going to be basically, can you comprehend these programs? Less on the, there's probably going to be some writing questions, but they're not the vast focus of the majority of this. Again, once I release the practice exam, it will be very easy to see that. You'll get at least a week's heads up on the practice exam too. So I won't release the exam unless you have a full week to prepare for it. Okay. Any questions about that? Again, it's not something it's not anything soon, but it certainly is looming, right? Typically, midterms and exams start around start around weeks 4, 5, and 6. 5 seems to be the very, seems to be, for exams that like to give out for classes that like to give 2 exams, a lot of them give them out on week 5 and week 6. So just keep that in mind, that things can it's not just this class, other things can get intense. So remember to pace yourself. Okay, so this week's modules, I have the instructions to watch these videos / go through the textbook on Monday. There are no textbook problems for this one because these talk about debugging and how to import in Python and basically external libraries and stuff. Basically, how do you debug problems, runtime errors, importing libraries and stuff. Note that the second video, I'm going to pull up the second video on this playlist for a second, though. So let me go ahead and, which is simply entitled, the most common import issue in Intro to Python classes. It currently has, I think I have it so it's in privacy mode for a lot of the videos, so it doesn't really track the views that come from this class or are played in the embedded video. So this has 6,400 views, meaning that people stumble across this video because they're Googling this issue. Simply put, this issue is comes about because you name a file on your computer turtle.py or random.py, and suddenly when you go to import turtle, things go wrong. They don't work. This is because when you're running a turtle program, what it's going to look for is that it's going to look for things in the current file structure that you're on. For instance, if I'm on my desktop and I wrote a program and did import turtle, it's going to first look on the desktop for a program called turtle.py. When it can't find it, it's going to go and check, okay, is that in the library? Is that in the built-in library for Python or one of the ones I've downloaded by pip? And if it can find it, then it loads it up, which it will because it's part of the internal library. But first, it looks in your local area. So that's why if you name a file turtle.py and you try to import that, you'll just be trying to import a program you're most likely trying to run. In fact, you can get into a circular import error. So just keep in mind, if things aren't making sense, make sure you didn't name something random.py, math.py, or turtle.py. The last one being the most common. So these are, again, very straightforward because what we're focusing on is Project 4 from the book, which is about drawing turtles. 1 second. So we're going to go ahead and click on this one. We can also get there by going to runestone.academy. Okay. Get into our course. Click on, scroll down to where the textbooks are. I'm like 400% zoomed in here. Foundations of Python Programming. Once you're in the book, you can scroll all the way down to projects. And we're going to do Project 4, drawing a circle with turtle. Now, again, I like the way this book works because it does present things in a very logical manner for this. And our objective today is to draw a circle of a certain radius, right? And a circle is basically defined by basically where its center is, and then you have a radius to define this curve around that center point. There's probably a horrible mathematical definition for it, but essentially, again, what we define as a circle is its radius and the location of its center. Now, drawing a circle is going to be a bit of a challenge on this one because, I can't even draw one on paper. It ends up just being a lopsided oval, right, of some kind. But this is one of those cases where we're going to start with a solution and work up, okay? And so we're going to start with maybe a bit of a simpler task than trying to just immediately draw a squirrel. We're also going to have a slight philosophical discussion in the middle of this, or aside, probably not discussion, because I'm just going to ramble. All right. So the idea here is that we're going to start with this, and we're going to start a pattern of this. So again, remember with these small program boxes, you can drag them and make them as big as you want. So we're going to start with our first one, which is instead of doing a circle, we're going to do a triangle. Okay? Ask the user for a side length and then draw a triangle. And again, we're going to be doing this using turtles. So to get you started, just to remind you how this works, again, we do import turtle, right? For your first line, that's the first magic line. And then the second magic line that we don't need to understand and just have to have memorized, because I don't like magic, but in terms of having to, or like considering things magic, but for right now, we do that. We say, whatever the variable name is, I'm going to call mine Bob, is equal to, and then we give it the actual memorized bit, which is lowercase turtle dot uppercase t turtle, right? And the casing matters, right? So import turtle, Bob is equal to turtle with lowercase, that's this over here, the package, dot turtle. Okay. Now once we have that, we can start doing things like moving him. I think we can do like bob.shape to actually make him a turtle if we wanted to. Right, and then bob.forward to refresh your memory, to move him forward 100 pixels. Okay, and he moved forward, and there we go. So did not turn him into a turtle. Maybe it's got to be underscore. It's a lowercase. Yes, it is. It's all lowercase. Feel free to change him into a color other than black, by the way, but black should show up fairly well on the screen over there. Right? We just simply, all we did was create a turtle. I changed his shape. You don't have to. And then I made him move forward 100 pixels. Okay. So I will introduce the for loop in a bit, but for right now, work on your best to draw this triangle. To draw a triangle using this. What is a triangle? Specifically here, it's probably going to be easiest if you draw what type of triangle? Equilateral, right. Equilateral, meaning everything is, all the sides are the same, and therefore all the angles are the same. Or all the angles are the same, therefore all the sides are the same. So probably be easiest if you do that. In fact, we're going to be working with regular polygons, meaning that everything is going to be assumed to have the same internal angles. So go ahead and do that. And then I will come back to you with this. Cool. So anybody want to talk about what the instructions were to get this turtle to make an equilateral triangle? Yes.
So I did a for loop, and then I did bob that forward and the length
right.
put in, and then I did bob that left angle so that it did the angle.
Yep, bob left, and what's the angle that you put in?
I put in
120. Okay. So I'm going to do this. I'm not going to do a for loop yet, but I'm going to copy and paste it. Right? It's a triangle. So what we're going to do is we're going to go forward 100, turn left 120 degrees. Doesn't matter if it's left or right, to be honest. You're still going to end up with a triangle regardless, right? It's just going to be pointing differently. Then we go forward, turn left 120, then go forward and turn left 120 again. Let's go ahead and run it and see it in action. Oh, sorry. Let's go ahead and see it in action. There we go. So let's go ahead. Okay. right? So that's what it does. Now, one common mistake I see is because you've had a bit of geometry knowledge just drilled into your brain, is to do this, to turn, when you're making your turns, to go 60 degrees, which ended up being like this. Now, the reason for the, and you know this because for any, it's got to add up to 180 degrees, right? Right? But that's the internal angles for a triangle, right? So if I just simply, let me get the whiteboard for a second. Promise I'm not going to subject you to too much geometry here. Give me a second. Okay, yeah, accidentally hit the wrong button. Reload it, and whiteboard. And you know what I brought? I finally unpacked from my trip to Japan. I found my electronic pen for my laptop. So, yay. Let's see if it actually works again, though. All right, so triangle, right? Poorly drawn triangle, I should add, right? If it's an equilateral triangle, they're all of length, all the sides are of length A, right? And this is 60 degrees, and this angle is 60 degrees as well, right? But those are the internal angles. If I extend this line a bit more, this external angle is 120 degrees. And when Bob is moving, and now let me go ahead and change the color. When Bob is moving this way, right, in order to be going to turn here, he's not turning the internal angle, he's turning the external angle, right? So he's turning 120 degrees. That's why we're using 120 degrees. And notice that because we turn 120 here, then we turn 120 here, we go this way. And then if we wanted to face this way again, we have to do another 120 degree turn. That's 3 120s, 120 plus 120 plus 120 equals 360, so that's a full degree, that's a full turn, full rotation. Okay. So again, okay. So now let's go ahead and just change it so now we get so that we take user input. Or I'll add that at the end actually because I'm going to add that at the end for two reasons. First, adding in interactivity is always the last thing I add in because it makes testing a whole lot slower because I can't just hit the run button to test my code. I now have to hit the run button and type something else in, right? So I always like to add it last. The second reason, though, is because right, if it's an equilateral triangle and I'm changing it from being 100 to being some value like x or input or rate or side length, whatever the user wants, right, if I type that in, I'm going to have to make that change 3 times. And then if I go to square, and if you look down, it's square and octagon, and then I'd have to make those changes 4 and 5 times respectively, which seems like a terrible idea. So better to just be able to like repeat this. I copy-pasted this thing 3 times. Might as well just repeat it a few times. So the for loop has a lot of different forms. In other languages, they have one kind of format. In Python, we use something called the for each loop, where it iterates through each of the elements in something. Right now, and this is annoying with Python, where basically we have to say, ignore that for right now. Just memorize what this does, which is the range. I'm going to use underscore here. Underscore denotes that I'm not going to be using anything. I'm not going to be caring about anything right now in terms of like a variable or adding additional variables or complexity into my code. I just want to repeat something. Okay, that's what the underscore means. I just want to use the for loop to repeat something. You could put something x or I or whatever in there, but we're not going to use it. So that's why I'm using underscore. Okay, so for blank in range, And then I put in the amount of times I want to repeat something, which is 3. And then finally, a colon. So we've got 4 or 5 things to remember based on how you look at it. We have a for. We have a variable name. Right now, that's just going to be underscore. We have the in. The in is never going to change. It's always for in, and then something. Here, we're going to be, for the vast majority of this, for pretty much, I think, everything until we're done with exam 1, exam 1's only going to use range. So range is all we're going to focus on for a few weeks. For blank in range, and for right now, all you have to know is that if we do something range and then do this, that's the amount, and then a number, that's the amount of times we're going to repeat something. So for blank in range 3 means we're going to repeat the following 3 times. Next, we have a colon, which tells Python to expect an indentation. Those of you coming from C or Java or another programming language are about to suffer something horrifying yet liberating, which is that scope is determined by tabbing. Scope is determined by indentation. There are no curly braces in Python. You have been liberated from the draconian rule of curly braces, I guess. So what does this mean for people who have no idea what I'm talking about? This means that basically what is going to get repeated 3 times? Whatever's inside the for loop. And by inside, I mean indented into the for loop. By indented, I mean, notice the fact that there are four spaces in front of each of these. It can be however many. 4 is the default, so use 4, but it technically can be however many. If you hit tab, that's going to add another 4 spaces, right? So if you need to indent something and it's not doing it automatically for you, you can. Okay? So a for loop's going to repeat everything inside of it, everything indented inside of it, a certain number of times. So here, the code has been greatly simplified. We set up our turtle, and then we say repeat the following 3 times. Move forward 100, and then turn, we need to fix this, 120. And then it just runs 3 times. Now, the indentation is important, okay? Because the for loop repeats what's inside of it. If this left is unindented, right, if only the forward statement is indented, it's going to say move Bob forward 100 3 times, then make a single left turn. And Bob just simply, I guess, runs off the screen. I guess he's shy today or something. All right? So it repeats a certain number of times. Okay? For blank in range. And if we were to do this, and if we were to change this to like 12, it would run 12 times. Now, nothing really is going to change in terms of the shape because we're making identical moves, right? So he draws a triangle, and then he proceeds to draw over it again and again and again, right? So, okay. And then, so again, but it ran 12 times. If you wanted to count, it would have run 12 times. 3. Now let's go ahead and finish this off by adding user input. Okay. Side is equal, sorry, not call it side. I'm going to call it length is equal to, so the length of a side is equal to, and I'm going to do input, enter, side length. All right, you can call it whatever, you can put whatever input statement in. So I say length equals input, enter side length. And normally what we've been doing is that we've been doing this in separate lines where we've been saying, hey, now I get this as a string, now I need to convert it into an integer, right? Everybody, that seem familiar to everybody at this point with the input statement? Okay, so Alternatively, what we can do instead of doing that there is that we can just simply take the input and immediately convert it into an integer. Both statements work. I don't care which one you have. This one has the advantage of the code being shorter, but things get but the more nested kind of parentheses you get, the more unreadable it gets. This isn't too unreadable, but once you start getting open paren, open paren, open paren, it starts to get really unreadable, so avoid that where possible. So now, save and run, enter side length. I'm going to put in 150, and it's still going to draw the same triangle. Why? Why does it draw the same triangle? Yes? Exactly. I got this number, and I did nothing with it, right? This was actually an unforced error on my part. This is very common where I will just simply program something, create a variable, and then forget to make the rest of the changes. It is also something very common that's going to happen in your code. Difference is that I immediately know what's going wrong, and you got to make these mistakes. You're going to make these mistakes, and you've got to in order to basically be able to correct them immediately. So here, instead of moving 100, I'm going to move forward length. All right, enter side length, 150, and now we should get a slightly bigger triangle. Great. Okay, I'm going to go ahead and share this code with you, although you probably have your own code at this point. And now what we're going to do is we're going to take what we've learned, and I want you to try to use it to draw a square. Now square, right, that's a four-sided rectangle, that's a four-sided shape, four-sided regular polygon. All the shapes are the same size. So what angle should you be using? What angle does the turtle need to turn at? Yep, yes. You have a problem? All right, so everybody work on making a square, and then I'll come back and then we'll work on an octagon. And I'll talk about some benefits of being lazy. Should probably start recording again. What do we need the turtle to do to draw a square? Right? What we need the turtle to do is that he's going to move this way. And then we need to have him turn either left or right. It doesn't matter as long as they always turn in the same direction. They have to turn right 90 degrees, right? A 90-degree turn so that they can go and repeat the same thing. Basically, we got to do that move 4 times. Move forward and then turn 90 degrees. All right. Forward. So instead of doing this 3 times, we'll do it 4 times. And instead of turning left 80 degrees, instead of turning left 120 degrees, we're going to turn left 90 degrees. Okay. Run, and I'll ask it for a side length of 200. And there we go. Oh, again, the grid is a 200 by 200 grid. So why don't we make a small change and make bob.color red so that this will show up against the border a bit better. Save and run. And I'll make it 180 instead. There we go. There's Bob. And we drew a square. Okay. Now, the next step, this should get to be fairly straight. So I'm going to give you a bit more time to do this one, even though a lot of you will get it quickly. There's a couple of nice tricks we can use, but let's go ahead and look at a side length for side 8. We want this program to make a shape with 8 sides on it. That's what an octagon is. Ask these are for side length, then draw an octagon. Blech. Kind of fumbled speech there for a second. All right. So yes, go ahead and work on that. I'll be walking around and helping out people as they need it, since I know I've been seeing a lot of raised hands. All right, so this is because they tile perfectly, among other reasons. Anyway, octagons. So, a couple of questions that I got asked, and if one person's asking them, then another person, then of course there's like 5 to 10 other people who are wondering. Somebody was wondering why do they need to put int here? And the answer is whenever we're typing in input, okay, every single physical glyph, every key you hit on the keyboard, okay, is text. All those numbers, when you're hitting it on the keyboard, that's a glyph. It's a character. It's not a number, it's a glyph representing that number, okay? I know that sounds weird, but then when we throw the int around this, it says, okay, take whatever text we had, whatever string of glyphs, whatever string of characters we have, and I want you to convert that into the actual numerical values so that we can do like stuff like addition or subtraction with them. And that's what the int does. All right, so we're going to go ahead and copy this, and we're going to paste this over here. And now we know this has to go with, if it's an octagon, based on the previous patterns we had, it should be 8 times. Do this 8 times. Now, personally, I have no idea what the angle is. Honestly, I don't. It's 45 though, right? I mean, I say I have no idea, but like I didn't memorize that before coming to class. I don't need to. How can I figure out what the angle is without looking it up? Yes. Yep. It would just simply be, well, since I have to repeat this 8 times and I have to make a grand total of, the total amount I turn has to be equal to what number? 360, right? Total amount of time, number of turn I have to do is 360. Each turn is going to be equal. So what, so I can, yeah, I see the lights going on there. 360 divided by 8. I'd say no math required, except that was math, but like the idea here is I don't have to figure out what the change is over here. So now if I put in something like 140, right, I get a nice big octagon. All right, I can make it smaller because again we're talking about side length. But now, so this is kind of an important idea here, okay, for helping us create a circle. And I'll go back around to that in just a second, which is, there's a couple, so now we've got up to octagons, so there's a couple different things that we need to kind of consider in order to fully make our circle. The first thing is that while we think of a circle as oh, thank goodness, I remember the name. As though we think of the circle as a completely round thing. In reality, it's not. In reality, you might think of a triangle. All right, I'm going to get really annoyingly pedantic here for a purpose, okay? Okay. I don't know why that is not working now. Okay, here's my annoyingly pedantic statement. Most people would say I just drew a triangle. I did not just draw a triangle. This is in no way, shape, or form a triangle. You have never seen an actual triangle in your life. Because every single this triangle, no, this is not made up of straight lines. There's curves in it. Those angles aren't adding up. What's this weird squiggle thing going on right over here? Oh, and this is extending out. This isn't a triangle at all. In fact, to be really annoyingly pedantic about it, uselessly pedantic about it, but there's a reason. I could say you could get a computer to draw a perfectly, as perfect as we could make it, and we could still argue about it because the atoms aren't right. Down to the atomic or molecular level, it's still not perfectly shaped like it. Now, the reason I am being annoyingly pedantic like this is that there's this idea called the Platonic ideal, where basically that everything, basically all these shapes that we draw are just these impure representations of an absolute ideal shape, right? An abstract shape of a triangle that we only can make pale imitations of. So the idea here is, though, For humans, though, this is a perfectly good triangle because it communicates the idea. So forget about the pedantry for a second. What matters is that it looks like a triangle to a human, and a human looks at it and says, that's a triangle. That's what matters, okay, in terms of our purpose. Similarly, I can't draw a circle like this. That was fairly good for me, but that's not a perfect circle. And you want to know something? Your computer can't draw a perfect circle either. Can't draw any perfect shapes because we're dealing with pixels here. Pixels on the screen means everything's all jagged and edgy anyway, right? But it's going to look like it, and it's close enough, right? So over here, what we can do is instead note that basically every time we've made a shape here, let's go ahead and make this a bit more of a shape. I'm going to make this size 40. Every time we make a shape, we went from triangle to square to octagon. And if I change this now to be a dodecagon, is that 20-sided? Let's go ahead and change it to 20-sided, right? Then I could, if I were to change it into a dodecagon, actually instead of just doing that, I will, let's go ahead and dodecagon, right? A dodecagon, okay, that's starting to look pretty circular to me, right? Okay, and in fact, because of my, I'm going over shape with my kids. Going over shapes with my kid. Pluralized the wrong thing. Going over shapes with my kid a number of years ago during COVID, okay, in the pandemic, and we're learning about a 6-sided shape is a hexagon, 8-sided octagon. Well, what's a million-sided one? And of course, you got to look that up because you're just itching to know yourself too. That's a megagon, by the way. Right? That's a megagon. It is a shape. It's a regular-sided shape with 1 million edges on it. It's a giant SVG file, so this is actually that shape. It does actually have a million sides to it. But that doesn't look like you wouldn't know. You'd look at that, and if I held this up, you would say, that's a circle, right? That's a circle. That's not a megagon. And if you were going to argue it's a megagon, it's useless, right? Because nobody could tell. You get what I'm saying? So what we're saying is that what I am saying here is that what we need to do to make a circle here is just make a shape, a polygon, that has enough sides that we can't really tell that it's a circle. Make sense? Enough sides to look like a circle without actually being a circle. Yes? You could do dot circle. Yes, there's a circle function built into Turtle. We could do it that way. But the idea here is to do it for yourself. So ask the user for a radius and draw something of that radius. So we'll get there for a second, but let's go ahead and say I wanted to make I'm going to go ahead and take this and move it down here into this one over here before we go into a circle, before we start getting it to be the correct size. All right? Ask the user for a radius, then draw a circle of that radius. So let's go ahead and say let's make it a 30-sided shape. A 30-sidegon. How would we draw a 30-sided polygon? What would we need to change here to make it 30-sided? Yes? Right. What should we change them to be 30? Yep, we just changed it to 30. To repeat the following 30 times. And the reason I chose 30 is that 360 is evenly divisible by 30. So let's go ahead. I'm going to make this small on the smaller side, like 10, because there's a lot of shapes, therefore a lot of movement. That's starting to look pretty circular to me, right? Okay. So of course, though, what we're putting in here is the side length. we don't need the side length. It says input a user, ask the user for the radius, and then draw a circle with that radius. All right? So let's just so while you're working on that, I'm going to give you a few minutes to work on that, and then I'm going to go back because I want to have plenty of time to talk about Lab 3, since I know some of you have questions about it. Okay, so remember, we really need to remember one equation for this, which is 2 pi r, right? 2 pi r. What's that equation for? The circumference. So the circumference. There's actually a terrible pun in the Discworld novels, which is about a giant world that's a flat world on the back of a giant turtle. And there's something that's put around the outside of the edge of the earth to catch things that fall off, and they call it circumfence. It's a terrible pun, but I've never forgotten it. The Discworld book's amazing. You should read it if you get the chance. But you're in college. You don't have the chance to do reading. You're too busy with reading other stuff. Yeah. All right. So why do I bring this up? Well, even though we're not drawing a circle, right? We're not drawing a circle here. So we don't have a circumference per se. The circumference, what the circumference would define in terms of the turtle, is that the turtle has to travel all around that distance. The circumference would be the total amount of, like, a distance that that turtle would draw. So if I wanted to draw something of a certain radius, I would have to make sure that the turtle went this far around, that the total amount of distance the turtle moved was this amount, was 2 pi r. So if I want the turtle to travel this amount, and it's a 30-sided shape, how long should each side be? Sorry? If it's a 30-sided shape, and the total amount of distance that the turtle is traveling is 2 pi r, on a 30-sided shape, how big is each side? Yep, 2 pi r divided by 30, or however many sides your shape has. So rather than moving forward, this length, you take in the radius, and then you do 2 times pi times the radius divided by however big you made your turtle, your shape to be. Okay? So I'll give you 5 minutes before I go over that, or a few minutes before I go over that. Once you're done, you probably don't want to leave, though, because I'm going to talk about Lab 3. Okay? So, yes. Yeah, go ahead. Oh, yes. So out that way, turn left down the first hallway you see. Okay. Thank you. You know, you really have to have time to dedicate to those. And I currently don't at the moment. All right, so for this one, because I want to make sure I have plenty of, I want to make sure I have plenty of time to just talk about Lab 3, since some of you have already had Lab, and I've been getting questions about them. All right, so for this, if I'm doing a 30-sided shape, this is the answer, and I'll explain why. 2 times pi times radius. I'm going to change this over here to enter radius, because again, it's asking us to put in a radius. Okay? And I'm also going to, and then I'm going to divide this by 30. So I'll run it to prove that it's the correct answer. Okay? Side, run, 100, enter radius of 100. 2 times pi. Oh, right, I don't have pi defined. So I'll just simply use 3.14. And 15. 100. And there we go. Circle of radius 100. And there we are. And the radius is, and I'm right. The radius is 100. This is a 400 by 400 square, I believe, because each dimension you can move 200 in. So that's about right. It's not perfect, but very little in life is. But I mean, it's close enough, and it looks like this. Now, I'm going to abstract it a bit more. Sides, plural, is equal to 50, or whatever. And I can do this. Sides, which will repeat instead of a set number of times, basically now it's going to repeat whatever this value is. And I can now just abstract that a bit more. So if I want it to be a bit less jagged, I can up the number of sides I have. So now if I do 100, that looks a bit more circly. Although he doesn't quite make it all the way between any errors in division over here and the inaccuracies in pi, they start to show up, right? But regardless, why am I doing the division by sides? Because the amount the turtle needs to move is 2 pi r. This has a certain radius. The turtle has to move 2 pi r the radius in order to draw the circle. It's not quite a circle, but we're pretending it is. So by moving 2 pi r, I get basically all that space drawn. So the last bit for that, that's for you to play with. If you want to try for yourself, use it for radius and draw a circle with that radius, but make the center the current location. Now the way we typically solve that, if you want to try it on your own, is that what I do is that if the circle is at wherever, let's say he's at 0, 0, and you're drawing something with the radius of 100, I make the turtle turn left, move down 100, and then turn right. So he's essentially just moved down the total amount of the radius, and then draw the circle. And then he moves back up to do whatever he needs to. Up or down, depending on whether you're turning left or right. Okay? Now, with regards to assignment 3, lab 3, once again, this is going to be really the start of things in the course seem a lot more complicated than they actually are. Okay, doing turtle loops. A lot of these are a lot more are not actually too complicated. The purpose is to give you practice on both using turtles and using for loops. Okay. Okay. Each of these exercises are worth 20 points out of 100. Yep, do not name your homework turtle.py. That's going to give you a world of pain. And I just simply threaten you with a 0 to make sure you don't do it. It's much easier to just follow that direction. Turtle Olympics, write a program or a function, if you know how, which uses a turtle or turtles to draw the Olympic ring logo. Right? So again, what is that? What does the Olympic ring logo look like? Olympics logo. Oh, it doesn't have its own article. That's interesting. Olympic symbols. There we go. That's the primary symbol of the Olympics. Now, for the extra credit, so basically for what I expect is 5 circles laid out approximately like this, each of the correct colors. Okay? What I want you what you need for the extra credit is the fact, notice here that with the yellow ring ducks under the blue ring over here, over the blue ring over here, under the black ring over here, and over the black ring over here. They're intertwined. They're not just simply laid on top of one another. It gives the illusion of going in and out to give a slightly 3D image, the barest hint of one. So correct overlapping of rings for extra credit. Got it? And the reason I mentioned that that's extra credit is because it's annoying to do it like that. For full credit, all you need to do is just get me 5 rings of the correct colors in the correct locations. Okay? Draw the turtle clock. Draw the face of an analog clock using a turtle. It should resemble something like this, although you are more than welcome to make it, more fancy. I've had some students actually have it give me the current time. That's well and above what you need to do. I just want you to get practice using stamp. Now, the big thing here is that this should be solved using this. Your life will be a lot easier if you use a for loop. You don't have to solve it with a for loop. It just makes your life easier because otherwise you have to do the same thing 12 times. So what I would do is I'd master doing this once, turn the turtle slightly, and then repeat it. Just basically do it once, because these are all just simply the same thing repeated over and over again. Okay? 3, draw your initials. Program or function you can use if your primary language is not English, feel free to, and uses a different alphabet, please feel free to do it in the, however you want, either in English or the glyphs of whatever your home language is. This is biased slightly against students who have the letter J in their name. So if you're Jeremy, I'm sorry, that J is going to be mildly tricky. But again, this one's just to have a bit of fun. There's no easy way to do this one, but there's plenty of ways to make it hard for yourself. Humans are great at making things hard for themselves. Draw a shape. This one is going to be coming up again and again, and pretty much you can use the solution we just did today in class for that, which is ask the user to input a number of shape to draw an n-sided regular polygon. That's exactly what we've just been doing, right? Just now you ask them for all the sides are the same, all the angles are the same. So, and we're asking them the number of sides. This one, definitely want to use a for loop. Oh heck! I even linked to the one we did today, although it's the generic link, not the link to your textbook. And then finally, draw the Triforce symbol from The Legend of Zelda, right? Which is, again, you can decide to do that by drawing 3 triangles, and just have the empty space be the fourth triangle pointing down as the empty space. Or if you prefer, you can draw one outer triangle with an inner triangle pointing downwards inside of it. However you so choose. You're given a lot of freedom. Okay? The extra credit is worth 10 points, so you can get a total of 110 on this one out of 100. That's quite a substantial boost. But keep in mind that the Olympics it's not hard so much as it's annoying. All right.